Hi, good afternoon, everybody. Thanks for joining this session. So my session is called Consumable Data Center Networks with Nuage Networks. I'm KK Lau from Nuage Networks. I'm a solution architect representing APAC based here in Singapore. Right. So today, I'm just going to give you a overview of what Nuage Networks is doing for the cloud computing in terms of virtualized networking. And who are we in terms of Nuage Networks? Nuage Networks is basically a Alcatel-Lucent venture. We're actually a spin-in company within Alcatel-Lucent itself. We're wholly owned by Alcatel-Lucent, right? And we are actually based out of Mountain View in California itself, right? So basically, we are reusing quite a fair bit of concepts that we have learned through the carrier space and bringing to the data center space itself, right? So our mission is basically to build the best-in-class technologies, overlay virtualized network solutions based on proven technologies that we learned from carrier space, and looking at how we can develop this in the best possible way for software development and application developers as well, right? So what we have seen today in terms of the cloud technology is changing the way that technology is being consumed today, right? So in the past where you have to actually wait for systems or servers or hardwares to be ready in order that you can consume it. But to today, when you have cloud system or web services that you can actually have instant gratification in terms of automation, in terms of consuming storage, computing, and networking resource. So thereby, not just the consumer expectation is shifting, but also in terms of developers and also cloud owners and application hostings are also changing expectation. Going down to the data center networks, where the compute resource today are virtualized. Today, this is very possible with computing platform like OpenStack, CloudStack, where virtualized environment can be available in minutes, and you can actually auto-instantiate all these capabilities. However, there are certain networks where it is still partially virtualized, where assets takes weeks or even months to provision, including things like router nets and VLANs to be configured across the data center to ensure within a data center port how one group of assets within the data center can access another. So typically you go through a change management, whether through the help desk, with the project coordinator getting inputs from various resource party, for example, the VLAN addressings, the IP address addressings, and the configuration for the LAN and so forth, and also the security team. So all this manual change could take days, even weeks. So even we could actually do compute virtualization. However, in terms of service velocity to deliver this to the end customer is actually hindered by this manual process. And increasingly more, we have seen more and more vendors and also end users alike are looking at software-defined data center network. We're looking at networking as a resource that can be virtualized. So some of the things can be done in very much in minutes and maybe in not so much more, but many elements are actually still configured manually, right? So there's this SDN controller that actually configures some elements, but there's still some manual configuration like firewalls and load balancers still need to do some changes, right? But what's lacking here today is still manual per tenant network configuration. That means it doesn't scale if it goes, if you want to go to multi-tenancy, or if you have some processes that still hindrance in you, right? In terms of replicating network configuration. So service velocity is accelerated, but there's still some rules or some policies that still need to be enforced across the networks itself. So what we are seeing today, even with automated or virtualized deployment, there's still some manual processes that still hinders the deployment of these automated networks. They involve committees to look at how networks are built, whether they are built according to network policies, and whether IP address assignments and so forth are rightfully assigned across the networks itself, right? And that only address part of automation problem because every time you have a new configuration change, you need to change across the entire network, and every piece of the network configuration needs to be authored and verified by the audit team itself. Right? That's why we have taken the policy-based approach to networking, where we look at policy templates which are application-centric to define the various parameters within the application itself in terms of zones, in terms of rules that each of the zones within, applications within can talk to each other. For example, across application tier 1 and tier 2, how can the ACLs look like, and whether it goes to the internet and how does the rules applies to those zones as well. So upon policy evaluation, right, the concept is that this policy evaluation based on the user type, the application types, and business rules, we can do instantiation of these policy templates into actual network application rules, right? And this can be reused multiple times and designed only once. So this way, we are striving for a open solution where Nuage Networks is looking at capability to develop based on SDN concepts to allow any of the compute environment, basically like OpenStack, right, to work with the Nuage Networks to create virtualized networks across multiple data center networking hardware, whether it's a predominant Cisco or Juniper or any other gears, or across any server or hypervisors, whether it is KVM or VMware. We can have a consistent capability and apply the same policies across these different system and compute resources. And we want to extend this services as across from a single rack across multiple racks, different zones in the data center itself, right? And this can also stretch across multiple data centers, as we are seeing with our scaling capabilities, and also into the WAN and reaching out to the VPN across the customer sites itself. And we are looking at a solution that not just providing for a private cloud, but looking at public or hybrid cloud deployment, that we can have a multi-tenancy approach, a policy-based approach to instantiate services, and a multi-tenancy capability to have multiple groups of users to consume the resources that's been defined. So the Nuage Networks VSP software platform, the virtualized services platform, actually consists of three main components. Firstly is the virtualized service directory, which is basically the analytics and business IT policy engine. Right, this gives you the capability to define policy templates and also service templates that can be reused again across a single enterprise or domain. We have our virtualized services controller, which is basically our SDN controller that allows the instantaneous programming of the network. This gives you the capability to define and to discover the entire network topology that's across and managed by the VSP platform itself. Lastly, we have the virtual routing and switching component, the VRS, which is the event-driven automation piece that sits within the bare metal assets or the hypervisors that allow us to have this integration and virtualized networking capability. So if we actually put it together in this overall view, the Nuage Networks Virtualized Services Platform gives you the capability to provide a virtualized network across your whole entire data center. So starting from the hypervisor, each of the hypervisor will have the VRS, which is basically an Open vSwitch implementation that will gives you the capability to bind virtual machines to the VRS, and this will provide the virtualized networking across the IP fabric in the data center, right? And today we can support both VXLAN and MPLS over GRE capability, right, to basically allow both layer 2 and layer 3 domain from the virtual machines across multiple resources in the data center itself. We have the virtualized service controller, basically the VSC as the SDN controller, as a means to program all these VRS, Open vSwitches, in terms of the flows, in terms of what capabilities or what rules each VM will have in terms of the ACLs and quality of service, right? And a VSD is where the definition of all these templates and rules that has been created on the Nuage platform itself. And of course, we have the REST interface that allows OpenStack or VMware or even CloudStack to have this similar resource across the network itself. So let's look at each of the component and what it does, right? So the Virtualized Services Directory, or the VSD, provide a virtual machine-based capability in terms of service definition. So on the VSD itself, your concept of organization and domains, and within each organization, you have multiple domains itself. And because it's multi-tenancy, each of the domains are segregated from each other organization itself, all in terms of IP management, in terms of ACLs, and in terms of zones within each of the organization. It also allows you to establish policy. This can be a combination of ACL, QoS, or even policy-based routing itself. We have a very strong concept of service templating, which allows you to basically build very powerful templates to be reused down the line with your other web administrators or database administrators in your organization itself. It has a powerful analytics engine and reporting. This gives you granularity into per VM statistics, and also creating threshold alarms if any of these virtual machines actually exceeds in terms of the network flows or packet drops. This can be defined on the VSD itself. On the VSC, this is a virtual machine-based component as well, right? This is our SDN controller, in the sense that it gives the capability to provide programming of all the data plane, which is made out of the VRS by OpenFlow, and is powered by our Alcatel-Lucent Service Router operating system itself. So in terms of capability of routing capability to interwork with the internet or even MPLS VPN, we actually have all the interoperability tested with major vendors, right? We have the concept of peering and federation, where this allows you to scale your deployment across multiple sites, right? So a pair of VSC, for example, can actually have up to 1,000 hypervisors managed under a single pair of VSCs, and this can scale across multiple data center or multiple pairs of VSC. It also does the auto discovery function of all the VRS, and also upwards towards the VSD it uses a chat protocol called XMPP to basically allows you to scale in terms of number of VSC in the network today and able to derive policies through the XMPP protocol itself. Inbuilt into the VSC itself, it also has inherent tenant slicing. That means it can actually host multiple group of IP addresses. You can actually have overlapping IP addresses and all within the same controller itself. On the VRS, on the virtual routing and switching component, this is basically the Open vSwitch based component that we have worked on. It provides both VXLAN and MPLS over GRE tunnels encapsulation options. So basically within the data center itself, you'll build so-called layer 2 tunnels between each endpoint via VXLAN, and each endpoint would be each of the VMs that you see in the network today, right? It will be programmed through the OpenFlow from the VSC, right? It encapsulates the VM into a preferred protocol, whether it's layer 2 or layer 3 itself, right? So it also allows us to detect the VM instantiation and teardown. So as and when a VM instantiated, you actually will look at the unique identifier on the VM and queries the VSC to see whether it has its policies. And once the VSC downloads the policy from the VSD itself, you program the VRS on the flow table in terms of how the forwarding of each of the flow coming out of the VMs will be done. And today we have multiple variants of VRS that's available. Today we have VRS for Xen, KVM, and also VMware. And we have a component called VRSG, which is basically a software gateway for bare metal applications and servers itself, where elements cannot be virtualized. This will serve as a software gateway. And also, if in the future there's any future support for hypervisors like Microsoft Hyper-V. So let me just do a walkthrough in terms of how this Nuage networks can interact with basically a cloud management system, like for example OpenStack. So in the first place, we can define all the different rules and domain capabilities on the VSD itself. That's one option, right? And then basically you can define within the organization itself what are the zones, and zones can be typically like web, database, or application zones itself. And then within each zones, you could have policies that are ties to each of the zone, which includes things like ACLs and QoS capabilities. And you can actually attach multiple subnets across those zones. Right? And then all this definition can be templated. We'll see a little bit of this later. And it can be instantiated multiple times for each of the user itself. So one, this has been done on the VSD platforms. In this instance, we are using example OpenStack. OpenStack receive a request for the compute access, and the VMs will instantiate hypervisors, right? So once this VM instantiation occurs, you actually will trigger the VRS, which actually would inform VSC that there's this particular set of VM that's coming up. So if this is the first time this domain or this service has been triggered, right, the VSC will query VSD policy, and the VSC will issue the VSC with the network service template via XMPP, and the VSC will program the VRS via OpenFlow in terms of the network requirement itself and the flow. And once the VM comes up, right, you will actually get IP assignment through the VRS itself, and also any traffic that egressing the VMs would be encapsulated by the VRS based on the layer 2 or layer 3 service that defined from the VSD across the network overlay. And this can work across multiple data center or multiple zones within the data center. And if you actually scale across multiple data we can actually have another pair of VSC to federate and extend the same zone across multiple data centers. This allows you to have very seamless means to access the same zone across multiple hypervisors or multiple data centers or across multiple geographical areas as well. And one of the key things that we have done is also to provide WAN integration in a way that we have MPBGP capability on the VSC. This multi-protocol BGP capability allows us to have a seamless integration in the WAN protocol, where we can actually input the IPVPN parameters like the route targets into the VSD itself, and this will allow the network service to extend across the WAN. And this part of the policy, in terms of what we're doing in policy, we actually are helping to drive the OpenStack capability as well. So this is some of the capabilities we are working with in terms of the Neutron. And this is based on the OpenStack group-based policy abstraction for Neutron. And what we are trying to look at is also in terms of application-centric approach to networking, where we're moving from the traditional construct of a Neutron plugins, where it just define ports and routers and subnets. But we're looking for abstracted interface for application developers to basically application components to connectivity, and also some policies governing that connectivity, right? And then this without looking at the details of the underlying implementation on the application developers. So this is what's been detailed in the group OpenStack group based policy abstraction for Neutron, where there's a concept of web contracts that between endpoints group that is associated from with association from one point to the other. So this gives capability to define what can flow between each of the endpoint groups, and how can this be abstracted at a higher layer itself. So we actually have done this in Nuage itself. For Nuage, we actually done this application-based policy for both virtual and physical networks since the first release. Right, we have a concept of zones and domains that allows you to have ACLs and QoS classification and enforcement, and that's the reason why we're also contributing to the group, in the sense that we are giving what we have done in the Nuage networks as a means of implementation of the application policy in Neutron. So before we go to a short demo, questions we have on the bridge itself. Okay, if not, I'll just give you a short demo into how the Nuage networks framework looks like. So what I have here is basically a live system that we have in our in the labs here in Singapore. So I can just and what you first see here is the first user interface for the Nuage VSD itself, right? So on the left-hand side, since we're logging as a what we call a cloud service provider or the super user itself, we have all the different organization and groups that's been under our charge itself. So for example, I have an organization called the Department W. Within it, it has its own domain groups and users, right? And likewise, I have another group called Layer 1, 2, 3. You know, so similarly, it has its own groups and domains itself. Within the domain, within each of our organization or the enterprise, right? They can create their own domains. And for example, where in this instance, I created a domain template, and this domain template expressly talk about 3 different zones. One is what we call the app zone, a database zone, and a web zone itself, right? So this capability allows you to define what are the parameters that cannot be changed or can be changed by the down level users that would consume this all these resources in the network itself. So this is a logical view, right? So you can instantiate a new instance, right? And I mentioned earlier, if you want to integrate with your WAN network, you actually just need to key in the route target and route distinguisher that's associated with the particular organization, right? So in this instance, I can create a new instance, I create project Y, and immediately you can see it inherits all the functionality that I have defined earlier. I have a database zone, app zone, and a web and a application zone itself. So within this, I can create multiple subnets within each of the zone. And so forth, right? So all this will be actually resources that will be consumed by the end user themselves onto what are the be instantiated by the virtual machine themselves, and so forth, right? So previously I created another domain. You can see from here, right? And then if you have remember clearly, she have duplicated IP address, but it doesn't matter because these are different instances, right? And then these are different instances that I can actually reuse the domains, and this gives you a capability to define a template, and this template can be reused, for example, for test administrator who basically just want to create the same template but with different subnets or even with different groups, and then define it multiple times. And then you can actually define this for the operation network itself with the same network build and without having to change the capabilities that are being defined earlier, right? So policies wise, there's also capability to define things like ACLs, right? So you can define what are the ACLs that is across this domain, for example, and then you can apply them to zones or subnets. So we make it pretty straightforward in terms of language-wise. We don't clutter the interface with IP addressing. The user can say that, well, I'm looking at an application zone to database zone, and I want to define a certain ACL, right? So let me create ACLs for this project. Right, and then basically I can build ACLs across this, right, between app zone and some app zone, or I can app zone and database zone, for example. I can create rules, right, that actually at different part of the IP packets itself, source destination match, port, or I can just drop it. Right. So all these capabilities can be done through the UI or can be done through basically the REST interface. Right. So ACLs you can do ingress ACLs, egress ACLs, and also advanced. So in terms of advanced, we have pretty complex. You can create more complex rules that looks at not just matching based on source destination, but you can actually look at the classification. You can override the DSCP marking itself. So this gives you capabilities to create more intelligent or more deep ACL rules for the app itself. So this in this organization, in this domain itself, I actually have multiple VMs that's been created, right? And then basically they are buying the different works that you see down. So all this instantiation is taken place automatically, right? When the VM starts up, you actually will associate itself to the different zones based on what has been provisioned by, for example, in this case, could be OpenStack or could be VMware itself. Right. So one of the capabilities that we have is also layer 2 domains. So these are basically point-to-point interface that we can actually create. So a typical use case for this is you could actually extend a certain set of VLAN groups across from one data center to another, basically without looking at the subnets or routing itself. Basically, we can actually define two different entities associated to a single domain, and basically they will build themselves as a single layer 2 the VRS will actually build a layer 2 network pipe across the two domains itself. Okay, any questions so far on the short demo that I gave? No, I carry on. So basically, the solution itself allows you to distribute layer 2 and layer 3 routing to each hypervisors. And then basically, within the VRS itself, you do the both layer 2 and layer 3 routing across from each of the VRS or the VM itself. It can work within the cloud, that means within the data center across different data center or across multiple clouds. Right? So there's no single choke point in the sense that there's no single gateway that all this traffic need to flow to. It can actually be going across the overlay across the network itself, either through the IP fabric, in the DC, or across the WAN to the other hypervisor itself. Right? And today we support multiple hypervisors or like KVM, LXC, and Zen, and also EXSI. Today we are working on plugins for both OpenStack and also Cloud Stacks. So very much coming to a close to my presentation itself. So we look at Nuage Networks to be able to create distributed virtual router and switches, which is great and much better than older models. This creates a distributed virtual configuration and management challenge, as we've seen. But provisioning and management cannot be done with traditional methodology. That's why we bring about policy abstraction model, right, through the BSD itself. Right? And then we have been shipping since May 2013. Right, so today we are already in our second release, release 2.1 on Nuage Networks framework itself. Right. So any questions that you have from the audience? So there's one question here is that does this only work with Nuage Networks hardware? So basically, Nuage Networks itself is basically a software solution, right? So there's actually not not in a sense any hardware capability that we have, right? So today the three components, the VSD, the VSC, and the VRS, all works within the VM itself. So we have used multiple set of hardwares that can be from HP, Dell, and so forth, and basically allows you to have um, the seamless capability to deploy it across multiple customers' networks. So, since we are working on an overlay solution, we also don't um, require any physical routers and switches to do interrupt, right? And then basically allows you to do these capabilities. Right, next question, or rather a comment to say that hope all the work are open source. For us, we are working very aggressively to make sure that whatever we work on in terms of Open vSwitch, we are contributing back to the community itself. We are working very hard with Red Hat ourselves to basically allow some of these capabilities to be certified and work with your system as well. Right. So today we are actually porting or rather making sure our VRS stack will actually work seamlessly across all the rail releases in 6.5 and 7, and coming on to 7 as well. And then also, of course, Red Hat OpenStack versions 4 and release 5 beta. Any comments or any questions that you might have? Yep. Okay, thank you very much for your participation today. Is there a way to open up the conference on audio that can everyone to discuss really? If not, thank you guys for this session.